Alright guys, so we're going to do this in like small snippets so you can do a little bit each day and kind of build on what you go. So we talked about on Monday conductors and insulators, different types of electricity, so static and current, different types of current electricity being alternating and direct. And so kind of continuing with that idea of current and then getting into voltage in ohms today is what we're going to talk about. So, if you have been paid any attention to appliances before, so microwaves, fridges, washers, dryers, whatever, appliances have the number of volts, amps, or watts written on them. And so that can tell you how much electricity is needed to make that appliance work properly. And so if you've ever had a circuit blow or a breaker flip, it's probably because there's too much of something that's causing it to trip. So the first thing we're talking about is volts. Voltage, which is measured by volts, is measuring electrical pressure or electromotive force. And so that light bulb is covering up the word force. But this is the pressure that moves electricity through a circuit. And so the higher the voltage, the more pressure that you have. And then if you've ever heard of amps, it stands for amperes, but it is measuring electric current. So how many of those electrons are flowing through that circuit. Then we're going to talk about watts a little bit today and then get into it more tomorrow. But watts are what measure electrical power. So how much power something gives off. And so if you have a high wattage, say a 1200 watt microwave, that's a high watt microwave versus like a 700 watt. And so usually it'll cook your food faster and, make it more efficient. But again, think of light bulbs. You might have a 100 watt light bulb or a 40 watt light bulb. Well, there's different purposes for different light bulbs. But watts is pretty much measuring the work that's being done by current under pressure. So how much of something is being pushed through is what is the watts. And so if you have kilowatts, it's a larger unit of power. And so if you remember from the science class, 1,000 watts make up 1 kilowatt, kind of like meters and kilometers. So there I said, 1 kilowatt is 1,000 watts. Sorry, I don't know why it's cutting off on my screen. Then we have resistance. And so if you guys are resistant to something, you don't want something to happen, kind of a similar thing in electricity. And so this restricts the flow of electricity from going through the circuit. Now, usually electricity will still go, but the more resistance you have, the harder it is for the electricity to flow. And this is measured in ohms. So if you ever hear of ohms, and today we're going to talk about Ohm's law. I think his name is Robert Ohm, is the one that came up with the idea of resistance that slows down that current and voltage. And so this is kind of a picture. It's equivalating electricity and water systems. And you guys are actually going to watch a video that talks about a similar concept either today or tomorrow. I don't remember which day. But you have this idea of having this generator plant or a battery, which if you equate that to water could be like your water tower. And then your water comes through these pipes. Here's like a reducer, so it slows it down and gets it a little smaller, kind of like a transformer. So if this was your generator plant where all your electricity comes from, you have a transformer that kind of limits what's coming out. Then you have a gate valve that you open up to let the water through, or if you think about the service entrance panel at your house, that usually has a big switch that either turns the electricity on, opens it up, lets the electricity flow, or it could close and stop that flow. Then you have the safety valve. So in water, you have the safety valve that if something happened, you could turn it off real fast. Kind of the same thing with a fuse, or we know it more so now as a breaker in your breaker box. A fuse is just an older version of that. So if you have a really old house, you might know what a fuse is. But that safety valve can be turned off real quick, or if something is wrong, it'll usually trip and kind of help prevent any issues. And so then the water flows all the way through this. In water, we measure things in pounds per square inch. So how much water is flowing through the current, very much similar to volts, which is how much electricity is being pushed through. Then you have the switch, so, like a light switch turning it on, or a faucet turning it off, an on in like a sink, and then an outlet, which is like where it's going. So, you plug something in or you turn a switch on, and then that allows electricity to flow, or if you think that a faucet, it allows the water to flow. So the amount of water that you actually collect, think of it like in terms of gallons of water that you collect, would be like the watts. So that's how much electricity that you have. But if you're talking about like gallons per minute, figuring out like how much water can come through in a certain amount of time, or like miles per hour in a car, that's kind of what amps is. So it's saying like how much can you get in a certain amount of time. So how many electrons are flowing through at that time, or how many amps are flowing through. This just kind of simulates the two together to make it maybe a little easier to understand. So today we're going to talk about Ohm's law, which is the relationship between pressure or voltage, the electron motion, so how much is moving, which is current, and then the opposition, or what's slowing it down, which is the resistance. And so we can say Ohm's law is the electric current flowing in a circuit, which varies directly with the electrical pressure and inversely with the opposition. So if your current goes up, then your pressure is probably going to go up. Or vice versa, if your pressure goes up, you're probably going to have more current. On the flip side, if your current goes up, then your resistance is probably going to go the opposite direction, and same thing with pressure. So when we do Ohm's law in terms of an equation, it's kind of weird, but I stands for current or amps. E is pressure or volts, and that E is short for electromotive force. And then R is resistance or ohms. So the equation itself is current is equal to pressure divided by resistance, or I equals E divided by R. So just as you guys are kind of working this out and listening to this, hopefully you're listening still, I think it's easier to put that the equation is E equals I times R. So I a lot of times do this as a circle, and I think they show you this in the video, so hopefully this helps. But if you do a circle and then divide that circle in half and put an E on the top half of the circle, and then the bottom half you're going to divide into quarters, so you have 2 quarters, and you're going to put I on one side and R on the other side. So you have E equals, or E over I times R. And so if you were to rearrange this equation, you would multiply both sides times R, and then you'd have E equals I times R. So then in that circle, if you cover up one of the whichever letter you're looking for, if you have E over I, if you're looking for R, or ohms, you can take E divided by I. If you're looking for the current, you cover up the I, you have E over R. So the voltage divided by the ohms. Or if you're looking for the E or the volts, then you take I times R because they're next to each other. So I know that's hard to explain, like, over a computer and not drawing it, and I know that stinks, but hopefully, if a few of you get it, spread the news with your classmates. I'm going to work through a few practice problems. I'm going to try to talk them through and then show examples, so maybe this will help you make sense with your homework. But the first question is, how much current flows in a light bulb that has resistance of 100 ohms and 120 volts of input? So first of all, you're looking for current. You're trying to solve for current. And so if you use that equation, I equals E times R, which is confusing, or if you're doing E equals I times R, you're looking for E. And so, not looking for E, sorry, you're looking for I. And so if you think about that, E times I times R, you're going to do E divided by R. So 120 was your E, or your volts. 100 was your resistance, or your ohms. So you're going to end up with 1.2 amps. Another problem, what is the resistance of a heater that is connected to a 120 volt source and has a current of 4 amps? So again, you're looking for resistance, so that R, or ohms. So your equation is going to be I equals E times R. Again, you're looking for this R, so if you swapped out the I and the R, you're really doing R equals E divided by I. And so, this takes you the long way around it, but you ultimately do 120 divided by 4, and you're going to get 30 ohms. Sorry. And then one more. So what is voltage necessary to provide a current flow of 10 amps against a total resistance of 50 ohms? This is what I was saying. If you're looking for voltage, so you have E on the top of your circle times I, E equals I times R. So you have 10 amps, or that's your I. You have 50 ohms, which is your R. You are going to take 10 times 50, and you're going to get 500 volts. Okay, that's where we're going to stop for today. So you have a YouTube video that you can watch that hopefully will help explain it a little bit better. And then you also have a worksheet to complete on Ohm's law. So again, if you have any questions, shoot me an email. Have a good day.